Hi, I'm Hayley from Parallel Coaching, and in this video I'm going to explain 3 simple steps for understanding muscle contractions. And if you stay until the very end, then I have a special level 3 anatomy download for you as well. The first step for understanding muscle contractions is to move away from muscles altogether, and we're going to use the accordion. We're going to use this as a metaphor to help us understand how our muscle contracts.
If you don't know what an accordion is, it's time to brush up on your folk music understanding. So really, an accordion, all you need to know about it is that it's a musical instrument. It makes a lot of different noises, but essentially it opens and closes. It kind of expands and contracts across this accordion length. So it changes in length. And this makes it a really good metaphor for us. So I want you to imagine for me that you've got many accordions all lined up end to end the whole way across. And what happens with this is that they're going to literally condense down and then expand back up. But they're not going to happen. That's not going to happen individually. They're all going to all do it at the same time, which means that there is huge variation in length from all of them being contracted to all of them being expanded. Now, what on earth does this have to do with anatomy and physiology, you may well be asking me? Well, essentially, each accordion is just like a sarcomere. So if you imagine instead that each accordion is a sarcomere that is stacked end on end, back to back. That's all I need you to imagine for me for now. I'm going to look in more detail at what a sarcomere actually is. So a sarcomere is made up of both actin and myosin. Now, an actin is the thin contractile proteins, and you can see on my screen here that you've got these lines across, these horizontal lines. These are the thin elements. They're the actin. And a way of remembering this is that actin is thin. They both have a T in them, so they're thin. Now, these basically need to join with the myosin, and the myosin is the thick filaments you can see that look kind of like brushes or caterpillars on here, that little centipedes. Now, these two contractile proteins join together to allow it to go from an expanded position that you can see here, that's the accordion expanded out, down to this contracted position here that you can see the accordion closed up. So, sarcomere is made up of actin and myosin. Myosin are the thick proteins, actin are the thin ones, and it just literally expands and contracts, expands and contracts. Now, have a look at this image here. Now, you may well have seen this image before. It's probably made you go a little bit grey, like mine has, or it's made you pull your hair out a little bit because you've seen it in your manual and it still doesn't make sense, no matter how many times you go through it. So I want to relate this to the accordion you've just learned about. Now, the accordion sits here. End on end, each sarcomere is sitting in a muscle fibre. So each muscle fibre is made up of a long lines of accordions. And remember, the accordion is a sarcomere. Now, a muscle fibre is also called a myofibril. Now, this myofibril runs the whole length of the muscle. But in order to have real impact and be strong, it needs lots of those for every contraction. So every contraction, we get to choose how many muscle fibres we engage. And that means all those sarcomeres are all contracting end on end. But if we have a bundle of muscle fibres, it's called a fascicle. And if we have a bundle of fascicles, it's then the skeletal muscle. So you can imagine there is a lot of actin and myosin, a lot of sarcomeres going on in every muscle contraction. Now, I want you to imagine this guy's arm here, and imagine this, for example, is happening in his bicep. I know it's showing it down in the forearm, but let's imagine the bicep. Now, from there, imagine now that each of his actin and myosin all contract and the accordions all get shorter all the way along. All of them get shorter. So each sarcomere gets shorter and shorter and shorter. Now, you can imagine the whole length of that and the strength of there being loads and loads of muscle fibers literally contract it. So as that contracts it and makes it all shorter, his two muscles, his two bones, i.e. his humerus and also his radius ulnar, get closer together, which causes a contraction and the joint closing, the elbow joint closing, which is his bicep curl. So essentially what you need to know is that a sarcomere is the actin and myosin, and that's where the contractile proteins are. That's what's allowing the contraction to happen, and they need to happen end on end to have significant difference.
So now you know everything you need to know about muscle contractions, and hopefully you feel like you have a good understanding. So let's test your knowledge with this mock question. The question is, what is the name given to the thin myofilament? And your optional answers are A, sarcomere, B, actin, C, myosin, or D, myofibril. So what I want you to do is to take your time and really work through this question and give it an answer, and pop that answer in the comments box below. That will allow us to see how you're getting on with the questions. And also, if you've got any questions, you can leave those there as well. So the answer is B, actin. So actin is the thin myofilament within the sarcomere. Also, if you're preparing for your level 3 Anatomy and Physiology exam, you could download 101 mock questions just like this one. All you need to do is click the link that's with this video. Also, please leave a comment below with your biggest takeaway from this video. I look forward to reading your comments and answering any of the questions that you may have. If you've liked this video, make sure you hit the like button, share it with your friends, and be sure to subscribe. Thank you so much for watching, and I'll see you on the next video.